Hello students, welcome back to my channel. In today's session, we are going to learn another algorithm, and today's algorithm is going to be finding the kth smallest element. So first, let us go ahead and see the problem statement. The problem statement says that find the kth smallest element in a randomly ordered array of n elements. So the point here, what we need to note is the array what is given to us is randomly ordered, which means it is not sorted. Suppose it was a sorted array. For example, let me take 20, 30, 40, and the kth element I need to find, k is equal to 2. I can simply choose the second one, and I know that this is the kth smallest element. Then there is no complication at all. But here we are talking about randomly ordered, which means it can be in any order. So though it is not in an ordered array, we have to find the second smallest element. So that is what the task is. So as you can see in this, first I need to kind of sort it, or I need to find a way in which I can find the second smallest element, kth smallest element. That k is the position we are talking about. So in this case, even if it is not ordered, our algorithm should give us the output as 20. So this is what the problem statement is. I hope it is clear. So how we can go about this? So the logic what we are going to be using here is, so in the previous session, we have already seen an algorithm where we learned about how to do partitioning of the array. So something similar is what we are going to use. There also what we did is we took an array, and then we took some pivot value, and based on that we tried to partition the array, like values which are greater than that particular pivot value is on the other side, and on the left hand side we had the values which are less than that, and we placed that particular pivot in a correct position. Now this is a algorithm which we have seen in the previous session. So the similar kind of a method we are going to use, because as you know, if at all I have a given array, I can use one method is I can completely sort it first and then find that kth position and display it. That can be done, but sorting an array is very expensive. But we are only looking for that particular kth smallest element. Hence, we are not going to sort the entire array, but we will try to find out a logic where I can just sort it up to a value where I can find the kth element, and then I know I'll stop there instead of sorting the entire array. So that is what is the logic I'm going to be using here. So like I told you, it is a partitioning array method what we are going to be applying, right? So this particular partitioning method is also used in another algorithm which is called as a quicksort, which we will be seeing in the coming sessions. But if you learn this kth smallest element, that will be helpful for us in order to learn the quicksort as well. So that is what I mean. Okay. So first, let us see. Let me just take some example. So how it is going to work is, if I'm taking an array, for example, 90, 10, 30, 20, 70, 60, 40, 50, 100, and 80. Suppose this is the array I've taken. Now, suppose the k value is 4. That is the fourth smallest element I need to find out. So if you see here 10, I have 10, I have 20, I have 30, then I have 40. So my output should be 40. So according to this, according to the problem statement, my output should be 40 because 40 is the fourth smallest element. So what logic we are going to use is, I'm going to use the values lower bound and upper bound are the two variables I'm going to use. And also I'm going to use the variables I and j. Just like how we used in the partitioning of the array, I'm going to go towards inwards with the variable I, and even with the j, I will go inwards until for I value, if at all I'm getting a value which is greater than the fourth element. As of now, randomly, I will take k is equal, since it is k is equal to 4, I will take that fourth position value, and all the values until I'll get a value which is greater than 70, I'm going to continue moving inwards. Similarly, I will continue moving the j value inwards until all the value which I'm getting is it should be greater than the 70. So the moment I find a value which is greater than 70 on this side and less than 70 on this side, I'm going to simply swap those 2. Okay, like this I'm going to continue. This will continue until lower value is less than upper bound. Only when this satisfies, I will be using this particular condition in order to swap the elements. So I will continue searching and swapping until my lower bound is less than upper bound. Meanwhile, I'm also going to reduce my bounds, as in I do not want to search in my entire array. Okay, so as in when I'm swapping, I'm also going to check if the value, whether the my lower bound value, that is whether I has reached, whether I has become greater than k. So if I has become greater than k means I have crossed the particular kth position, which means immediately I will reduce my upper bound to j value. Similarly, if the j value has become less than k, which means my k position is over here, but my j value has crossed k, means when this situation occurs, what I'm going to do is immediately I'm going to change my lower bound. Lower bound will come to I position. Okay, so like this iteratively I'm going to continue to sort it until this particular condition satisfied, that is my lower bound should be less than upper bound. And then once that happens, I will get my kth smallest element. Okay, probably if you have not understood when I'm explaining like this, it is fine, because we will see the same example. We are going to step by step iterate the algorithm and we'll see how it is going to work. So let us see the algorithm first. Okay, so this is an algorithm. So I'm going to read the array of n elements. Then I'm going to set L is equal to 0. So lower bound is going to be 0 and upper bound is going to be the number of elements minus 1. This is because I'm going to subtract 1, because as you know that array has a subscript starting from 0. If you have 9 elements, which means I have 0 to 8 elements, which is once again nothing but 9 elements. Okay. Also the kth position also I'm going to say, if suppose the kth element I need to find is fourth element, then I have to, according to the array, as you can see, it is 0, 1, 2, 3, 4, 5, 6, 7, 8. Kth, fourth position is nothing but 3. So 0, 1, 2, 3. So this is the fourth element. That is why we also say that k is equal to k minus 1. That is all the reason for subtracting 1, mainly because the subscript of the array is starting from 0. All right. Now, next is, like I said, all the steps, whatever we are going to perform, comes under the main condition that your lower bound should always be less than your upper bound. All right. So once that is true, after that only I'm going to set x value is equals to a of k. K is nothing but the element which I'm going to find. I'm going to store it in a variable called as x. Then I'm going to set I is equal to L, and also I'm going to set j is equals to u. All right. So once that is done, I'm entering, this is my first while loop. I'm entering the second while loop. Here I'm going to check whether I is less than k and j is greater than k. All right. So if that is true, I'm going to enter my third while loop. So here I'm going to check for the value, whether the ith position is the value, whatever there in the ith position, it should be less than x. The moment it is more than x, I'm going to come out of this while loop. Similarly, for this should be j. Here, if x is less than a of j, then only I will reduce. Reducing as in I want to get inward. When will I stop? I will stop the moment I will get an x value which is greater than, as in the value which is there in the array is greater than the, less than the x value. I will stop it. And whichever position, I and j position I'm there, I'm going to swap those two values. So here C is, we are going to swap those values, as well as I will increment I is equal to I plus 1 and j is equal to j minus 1. Please add these two steps. So you have A where I have a while loop, B where I have a while loop. This is my fourth while loop. Also, the Cth step is I'm going to swap. The moment I will stop this, I'm going to swap those values and increment the I value as well as j value. So once this is done, once all these both the while loop fails, I'm going to check if L is greater than K. If L is greater than K, then I'm going to set my upper bound to J. And if j is less than k, sorry, this is not L, this is I. If I is greater than k, then I'm going to set my upper bound to j. Similarly, if j is lesser than k, then I'm going to set my lower bound to I. Okay, so this is how algorithm works. So as you can see, we have a very first while loop. Inside that, I have another while loop, and then within that, I have two more while loops. So here it is nothing but a nested loop. So before we get on to understanding how this algorithm works, first let us talk about the how does a nested loop work. Okay, so I have a while loop and I have another while loop with the second condition. Then I have a third while loop with the third condition. Now, always remember that once this becomes true, only then I'm going to enter here. If this is false, then I'm not going to do any of this. Instead, I will directly come to the statement which is after the close bracket of this main while loop. Similarly, once I'm entered here, the condition, if it is true, then I'm going to execute this. If this is, suppose this is false, then I'm not going to execute this. I will execute the statement which comes after the close loop of this particular while loop, which is in this case here, it is nothing but I'm going to, if this is failing, I'm going to come back to the main while loop and check the condition. Similarly, the inside, the third while loop, if it is the condition is true, then I'm going to execute the statement. If it fails, I'm going to come out of this into the middle loop. All right. So how does this loop then? So this loops, once this particular while loop fails, then we are going to come back and check for the internal while loop. If this is true, once again, we will enter the internal loop and execute until it becomes false. And this will continue until the middle loop becomes false. The moment this becomes false, we are going to exit from this loop and come back to the outer loop and check for the condition. If this is true, suppose this becomes true, then in that case, once again, we will enter this middle loop and hence the third loop. So this will go on continuing the same thing which we are going to see just, okay, because as I told you, it is nothing but we have three nested while loops here. So let us start. Now, this video might become very lengthy as because I'm going to take a 10-digit array and then we are going to continue iteration until we are going to get our values. So I request all of you to take a book and write down simultaneously with me so that it is easy for you to follow through, as I can write it in this page, and the moment I'll land on a particular array after swapping, I'm going to erase all that and write a new thing. So that's the reason I request all of you to write it down along with me, right? So let us take the same example. I have 90, 10, 30, 20, 70, 60, 40, 50, 100, and 80. Okay, so I hope you have taken the screenshot of the algorithm. If not, please go back and take a screenshot so that you can follow through it. So the very first step tells us that we have to initialize the value of lower bound, which is nothing but 0, upper bound, which is nothing but 9, and k, it is given that kth element what we need to find is 4, which is nothing but 4 minus 1, hence it is going to be 3. Okay, so this is the initial values what we are going to get. Next, we are going to start with our first while loop. So here we are going to check whether the lower bound is less than the upper bound, which is nothing but 0 is less than 9. Hence, it is true. Hence, I will enter the while loop. Now, inside the while loop, I'm going to initialize the I value to lower bound value, which is nothing but 0. Then the j value is I'm going to initialize it to the upper bound value, that is 9. And x, I'm going to initialize it with a of k. K is nothing but 3, and we have a of 3. Here I'm going to, let me just write the subscripts here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so this is our subscript. So hence we are going to get a of 3. 3 is nothing but here 20. So this is the initialization we have. Next, this is my first while loop. This is true, hence I'm getting inside. Now next I'm going to check that while 0 is less than or equal to 3. So 0 is less than or equal to 3 is nothing but I'm checking whether I is less than or equal to 3. And also I need to check whether 9 is greater than or equal to 3. That is whether the lower bound is less than the k value and upper bound is greater than the k value, which both are true. Hence, I'm going to enter the while loop. Next, this is my second while loop. Next, now we are getting inside. Now I'm going to initialize the I value. As you can see here, let me just change the color. I is here, J is here. Now, like I told you, I'm going to move inward and inward until the condition fails. Okay, so I'm going to check if A of initially I value 0, if A of 0, which is 90, according to this, it should be less than the X value, which is 20. As you can see, it is not, it fails. Hence, I'm going to stop this while loop here. Next while loop we have is while. This is another while loop we have. Next while loop we are checking is whether A of J value is 9, A of J, which is 9 value, A of 9 is 80, it should be greater than the value of X, which is true in this case. Hence, I'm going to reduce the J value to 8. Next, I'm checking if A of 8, which is nothing but 100, is it greater than 20, which is also true. Hence, I will reduce the J value to 7. Next, I'm checking A of 7, which is equals to 50, whether it is greater than 20. Yes, it is true. Hence, I'm decrementing the J value. Next, I'm checking A of 6, which is equals to A of 6 is 40, which is also greater than 20. Hence, it is true. Reduce the J value to 5. Then A of 5 is equals to, we have 60, which is greater than 20, which is also true. Hence, reduce the J value to 4. Next, A of 4 is equals to, we have 70, which is greater than 20, true. Hence, reduce the J value to 3. Now, A of 3, okay. Now, A of 3 is 20, which should be greater than 20, but it is not. Hence, it fails. Okay, so remember we have stopped at I value is equal to 0 and J value is equals to 3. So what is the next step? Once this is my third while loop, this is my fourth while loop. Once both the condition fails, we are supposed to swap the value. Hence, we are going to swap. So what we are going to swap? We are going to swap A of 0 and A of 3. These two values are going to get swapped. Hence, we will get a new array. After swapping this, we will get a new array. So once you swap, you also need to change the I value and J value. So I value is going to be now 1 and J value is now going to be 2. All right. So once we do that, change the I and J value, we are going to check the if conditions. So we will check if J is less than K. So in this case, J is 2. Yes, it is less than K. So when this happens, the condition is you have to change the lower bound to I. Hence, the L value is going to change to now 1. Also, we will check if I is greater than K and I value is 1, which is not greater than K. Hence, the U value will not have any change. U value is still going to remain 9. So these are the new I and U values. And then we will now continue with the new swapped array. Okay. So I'm going to erase this. I hope you all have written. Now we will start the second iteration. So after changing or after swapping, the new array what we have is, we have 20, 10, 30, 90, 70, 60, 40, 50, 100, and 80. This is the new array we have. Let me also write the subscript 0, 1, 2, 3, 4, 5, This is a subscript we have. All right. And we also know that we have changed the lower limit is now 1. Upper limit is going to remain 9. And our x value is now a of 3, which is nothing but 90. Now the x value has changed. Okay, now we are going to check the while condition, that while lower bound is still less than upper bound, and now we will initialize. This is true, hence is the first iteration. Now this is true, hence I'm going to initialize my values. I is going to be 1, j is going to be 9, and also of course our x value, which we already know, is going to be 90. Now I'm going to check my next while condition, that while 1 is less than or equal to 3 and 9 is greater than or equal to 3. This is also true in our case, hence I will move on to this is my second while loop, third while loop. The third while loop is nothing but we are going to initialize the value of I and j, and then we are going to look for values now. So now I'm checking whether array of I, whether it is less than the given x value. So array of 1 is going to be 10 and it is less than 90. This is true. Hence, I'm going to increment the I value to 2. Now, array of 2 is nothing but 30, which is also less than 90. True. Hence, I'm going to increment the I value to 3. Array of 3 is equals to 90, which is not less than. Remember, we do not have a equal to, hence it is not less than. Hence, we are going to stop here. Next, I will directly move on to the next while loop, fourth while loop, where I'm going to check while a of j value is 9, whether it is a of 9 is 80, this should be greater than the given value. And as you can see, it is not, hence we are going to stop. So now what we need to do is we need to swap the values for I is equals to 3 and j is equals to 9, which means I'm going to swap the values. I is equal to 3, 90, and I'm going to swap the values with 80. All right. So when I'm going to swap, I'm going to get a new array. Remember, after doing the swapping, we are also going to increment the I values. So I value is now going to be 4 and j value is now going to be 8. So once this happens, we are also going to check for the if conditions. So if condition tells us that if j is less than k, in our case 8 is not less than k, hence nothing, we are not going to do anything. This is false. Okay, next I'm going to check if I is greater than k, which is of course the case because 4 is greater than k, which is true, which means now I need to change my upper bound to 8. Okay, so when I becomes greater than k, we need to reinitialize the value of u to j. So now my new lower bound is 1, my new upper bound is going to be 8. These are the new values which I'll be doing my third pass. So the new value of after swapping those I and j, it is going to be 20, 10, 30, 80, 70, 60, 40, 50, 100, and 90. Let me also write the subscript for this. Subscript says 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We know that the lower value, lower bound was 1 and upper bound was changed to 8 in the previous one. Now let us check the while loop. Now while loop says that lower bound should be less than the upper bound, which is true in this case because 1 is less than 8. Hence the first loop becomes true. Now let us go to the second loop. In the second loop, we are going to check that whether I is less than or equal to 3. I value, okay, before that we have to initialize the values of I. I is going to get the value of a lower bound. J is going to get the value of the upper bound and X is going to get array of 3, which is nothing but in this case we are going to get 80. So I'm checking whether I is less than or equal to 3. I is nothing but 1. 1 is less than or equal to 3. It is true. Also, I'm going to check whether j is greater than or equal to 3. J value, what we are going to get here, it is 8. Of course, this is also true. Hence, we will go to the innermost while loop where I'm going to check the value of A. So first I will start with A of I. In this case, it is A of 1. I'm going to check whether it is less than the X value. Yes, in this case, it is true. Hence, I'm going to increment the I value. I value is going to be, it is going to be 1 plus 1, which is 2. Next, I will check A of 2, which is nothing but 30, which is also less than 80. True. Hence, I'm going to increment the I value to 3. Now, A of 3 is equals to, I have 80. And here, when I come, I'm going to get stuck as because it is false. It is not less. It is equal. Hence, this is going to become false. Next, I'm going to check for the j value, A of j, which is nothing but A of j value I have is 8. A of 8 is nothing but 100. Is it greater than the x value? Yes, it is true. Hence, I'm going to reduce the j value to 7. Next, I will check A of 7. A of 7 is nothing but 50. Is it greater than 80? No, it is not. Hence, I'm going to stop the j value as well. Now what I need to do is I need to swap the values of I is equals to 4. Sorry, I is equal to 3 as well as j is equals to 7. I'm going to be swapping the value of I is equal to 3 and I is equals to these two values. I'm going to be swapping. After swapping, I value is going to become 4 and j value is going to become 6. This is the I and j value. Now we are going to check if j is less than k, which is of course not true. This is false. Next, I'm going to check if I is greater than k, which is true. Hence, I'm going to change the value of my upper bound. Upper bound is going to get the value of j, which is nothing but now the upper bound is going to get the value of 6. So the new values what we have is L is equal to 1 and U is equals to 6. Now we are going to do our next iteration based on L is equal to 1 and U is equals to 6. After swapping the values of I is equals to 4 and I is equal to 3 and j is equals to 7, we are going to get the new value as 20, 10, 30, 50, 70, 60, 40, 80, 100, and 90. These are the values. Let us write the subscript as well so that we don't get confused. Okay. So now, after that, we know that our new lower bound is 1 and new upper bound is going to be 6. Let us check now. While L is less than U, which is of course true. Hence, I'm going to get inside and initialize the values of I. I is equal to L and J is equals to U and X is equals to A of 3, which is nothing but now 50. All right. Now, next we are going to get and check while whether I is less than or equal to 3 and j is greater than or equal to 3. In both the cases, it is true because I value is less than 3 and 6 is greater than 3. Hence, we are going to go ahead and check now values of A of I and A of j. So we will check now A of 1, which is nothing but 10. Is it less than 50, which is true. Hence, I'm going to increment the I value to 2. Next, I'm going to check A of 2, which is equals to 30, which is less than 50, which is again true. Hence, increment the I value to 3. A of 3, which is 50, which is not less than 50. Hence, it is false. We are going to stop here. Next, let us check for A of j. A of j is nothing but A of j value we have is 6. A of 6 is equals to 40. Is it greater than 50? It is not. Hence, in the first attempt itself, we are going to, it fails. Hence, we are going to stop here. So I is equals to 3 and j is equals to 6 is where we have stopped. Hence, we are going to swap those two values. So I is equal to 3, hence 50 and 40. These are the values we are going to swap. Okay, so after swapping, I value is going to become 4 and j value is going to become 5. And then if I'm checking the value for the if condition, where I have to check if j is less than k. J value is 5. Is it less than k? K value is 3. False. So I'm not going to do any action here since it is not true. Next, I will check if 4 is greater than k value, which is 3. Yes, it is true, which implies that I'm going to change my upper bound to the value of j, which is nothing but 5. Hence, now the new limits are going to be L value is going to be 1 and U is going to be 5. I'm going to work on this now. Hence, we will do the next iteration. Now, let us write the values after swapping. The new array what we found after swapping is 20, 10, 30, 40, 70, 60. So as we know that the values have changed now. Now L value is going to be 1 and U value is going to be 5. So the first while loop simply checks whether L is less than U, which is true. Hence, I'm going to get inside and check for the next while loop. Before that, initialize I value to L, U value to j value to u, and x is going to be now, this is our third value, so it is going to be 40. Now we are going to compare the values for 40. Now I'm checking whether 1 is less than or equal to 3. Yes, it is true. And also I'm checking whether 5 is greater than or equal to 3, which is true. Hence, I will go ahead and check for a of 1, which is nothing but 10, whether it is less than 40. True, hence increment the I value to 2. A of 2, which is nothing but 30, it is less than 40. True, hence increment the I value to 3. A of 3, which is equals to 40, which is not less than 40. Hence, we are going to stop. Next, I'm going to check with A of j value, which is nothing but A of j value we have is 5. A of 5, which is nothing but this is 4 and this is 5, 60. 60 is greater than 40, which is true. Hence, I'm going to reduce the j value to 4. A of 4 is nothing but 70. 70 is greater than 40. True. Hence, reduce the j value to 3. A of 3, it is nothing but 40. 40 is not greater than 40, hence it is not true, hence we are going to stop. Now we have stopped at I is equal to 3 and j is equal to 3, so we have to swap. Even if we swap, since both the values are same, it is going to remain same. Once we do the swapping, we are going to increment the I value by 1 and decrement the j value by 2. All right. Now once we do that, what we are going to check is, I'm going to check if j value is less than k. Of course, it is true in this case. Hence, I'm going to change my L value to I. I is nothing but 4, which is nothing but now my lower bound has become 4. Also, I'm going to check if I value is exceeded k, which is whether it is greater than k. In our case, I value is 4 and k value is 3, which is also true. Hence, I'm going to change my upper bound to the j value. J value is nothing but 2. As you can see, the new L and lower bound and upper bound are 2. All right. So even after doing this iteration, our array is going to remain same because we are swapping at the same position. That is, we are swapping array of 3 with array of 3. Hence, this is going to remain same. As you can see, also our lower bound and upper bound has crossed over each other. As because now lower bound is more than upper bound and upper bound is lesser than the lower bound. Okay. Now, where this algorithm is going to stop. Now, after this iteration, what is the next condition? Once all the while loop fails, once again, we will go back to the while loop with the new lower bound and upper bound. And the condition for that is whether lower bound is lesser than the upper bound. In our case, it is 4, whether 4 is less than 2. Now, this itself fails. Because this itself fails here, what is we are going to do is, this is going to fail. Hence, as we know that we are going to come out of this entire while loop and we will stop. So if you see that algorithm, once this main while loop, which is L is less than U fails, what we are going to do is whatever the output, whatever the the array we have in that, we will simply print from the kth position, and the output is going to be the kth smallest element is nothing but count. So this is what is our output is going to be, and we know that from the array, this is the correct answer. So this is how this algorithm works. You might find it very lengthy. So if you follow it up with me, it is a very simple one until unless you know how a nested while loop works. Also, because I have taken a very lengthy array with 10 elements, you can take a smaller array and you can understand. My agenda here was to make you understand that what are the different situations which might arise. You might feel at some point that it is not going ahead at all, but still, if you go ahead and follow this algorithm, you will end up getting a right answer. All right. So this is how your kth smallest element works. If you understand this algorithm, in the coming sessions, we will be discussing the quick sort that is going to be easier for you. All right. So that's all in today's session, students. Thank you for watching. Keep learning. In case if you have any doubts, kindly put it in the comment box. Thank you.